So what does the graph of 1 over x look like? So let's start at 1. Let's put 1 here. Well, this is 0, that's y, that's x. So when x equals 1, what is the value of the function?
When x is equal to
1.
Oh, okay. 1.
1. So 1 goes with 1, about there. Okay, what about when x is 2? Now what is the value of the function? Half. Okay, so let's find a half, I'll put you there. How about when it's 3? What is the function when x is 3?
Quarter.
A quarter would be when x is 4. Yep. So a quarter will go there. When x is 3, you substitute 3. What do you get? 1 over 3?
1 over 3.
Is a third. 1 over 3. So we get a third. Huh? Not 3/4. Just, this is 1 over x. 1 over 3. So this is the point 3. 1 over 3. This is the point 2. 1 over 2. 1, 1. 4, 1 over 4. And we can keep going. 5, 6. What do you think those will be? At 5, I will have the point 5, 1 over 5. At 6, I will have 6 and 1 over 6. And I can keep going. And this fraction, 1/2, 1/3, 1/4, 1/5, 1/6, is getting smaller, right? Yes, Charles? Do you agree? So these fractions are getting smaller. And as I keep going in x, let's say I get now to x is 1,000. What is the value of the function? 1 over 1,000. Then I keep going even farther, 1,000,000. What is the value of the function? That's 1 over 1,000,000. These fractions are getting very, very small. 1 over 1,000th. 1,000th will be like down here. 1,000,000th, I can't even draw. My marker is too big. Yeah? But is it 0? It's not 0, right? 1,000,000 is not 0. 1 over 1,000,000 is something. It's a very small something, but it's something. 1 over 1,000,000,000. 1 over 1,000,000,000 billion. 1 over any number you want is very small, but it's something, right? It's not 0. Now, you can keep going forever. You will never reach, right? There is no value of x that here you would get 0. It will never happen. It will never happen. You will get smaller and smaller and smaller, closer and closer, yeah? If we draw this curve, you can see that it's getting closer to, this is the 0 line, right? The horizontal axis is the 0. So this graph of the function is going to get closer and closer to the horizontal axis, but it will never touch. If you keep zooming in, you will see, there's a little gap. 1 over 1,000,000, tiny gap. 1 over 1,000,000,000,000, smaller gap, but still a gap. It will never actually reach. But it's getting as close as you want. If you say, no, that's not, that gap is too big, make the gap smaller. I say, fine, I will go further and the gap will be smaller. And I can do that as long as you want. You can ask me to make the gap as small as possible and I can do it, right? So now we say the limit of this function, the limit of the function 1 over x is 0. So again, what do we mean? We don't mean that there is a point in the domain of this function where the corresponding value is 0. We have said that will never happen, right? This has a domain that goes all the way to infinity. You can make the numbers as big as you want, and you will never reach that 1 over x equals 0. Will never happen. But the numbers will get closer and closer to 0. And that's what a limit is. And visually, it's this line. You can see that the graph of the function will get closer to the horizontal line, but will never reach it. Now, we give a special name to this. The line that the function approaches, we give it a special name. We call it the asymptote. 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 And the asymptote can be anywhere. You can have horizontal asymptotes, you can have vertical asymptotes, you can even have angled asymptotes. It's a bit harder to construct such functions, but you can. But yeah. And usually we draw an asymptote. It's a bit harder when it's on the horizontal axis. So let me make a little change to our graph here. Let me call it, instead of 1 over x, let's call it 1 plus 1 over x. Let's say this is my function. Yeah? So now, this is 1, and 0 is, this is the horizontal axis. So now we have this would be 1.5, 1 1/3, 1 1/4, 1 1/5, 1 1/6. Yeah? Now the asymptote is the line y equals 1. This will get closer and closer to 0, which means we will be left with 1 plus something that gets closer and closer to 0. And we have a way of writing, instead of writing the words out like this, we write the same thing. So now it's not 1 over x. Of 1 plus 1 over x is 1. The limit of the function 1 plus 1 over x is 1. This function will get closer and closer to the line y equals 1. And we write that like this. The limit, what? Yes? The limit, as x goes to infinity, so as x, if you keep going in that direction, the limit of this, you can put it in brackets or not. So remember, here you write limit on the line, x goes to infinity below it, and then the function in here, and this will equal 1. The limit as x goes to infinity of 1 plus 1 over x is 1. How are we doing? Are we a little bit lost or completely lost? Completely lost. Who is completely lost with Ishmael? Yeah?
Yeah.
Mm-hmm. Where did we get lost? Did Zeno's paradox?
Yeah, I got that part.
Okay.
But when you say I explained about this 1 plus 1 over x.
Uh-huh. Okay.
This one,
Hmm?
this one, the word was 1 over x.
Did it make sense when we just did 1 over x?
Yes.
Okay, maybe I jumped too far. So if I just do the limit of 1 over x is 0. This part you're okay? Everybody's okay with this? Okay. So if you're okay with that, then think about what happens to this graph. This is good, actually. This is how you think about manipulating graphs of functions. If I have a function, and I have a function, f of x, y equals f of x. If I add 1, whatever this function is, if I add 1, what happens, yeah? And I have a function. Visually, what will happen to this function? If I add 1, how will this picture change? It'll go up, right? If this point was, this is a point x, f of x, well now x, y will be f of x plus 1. It will be here. And this one will go up by 1. And this will go up by 1, and by 1, and by 1, and by 1. And the whole line just moves up by this amount, right? And if it was a negative, then it would move down. You just take the whole thing and you shift it down. So if it was here, then it would shift down to here, that. Or if it's positive, then it can go up to here. So that's what happens when you add or subtract from a function. You just add a constant or subtract a constant. You're just shifting the graph up and down. Fine? So now if I have a function 1 over x, like this, and I add 1, what happens to my graph? All of the points on the line go up by 1. Right? That's why I added 1 to all of these. 4, now it's 1 1/4, not just 4 1/4. And so instead of moving the graph up, I moved the horizontal axis down, which is the same effect. But I realized that it might feel, usually the axes don't move on you. The graph, the function should move. But if this is my axes, this is the y-axis, this is the x-axis, this is y equals 1. Now my graph used to be here. This is 1 over x. This one. If I add 1 plus 1 over x, then I get this line. I just take this one and I move it up by 1. Yeah? Now think about what happens to what is the asymptote of this one? When you have 1 over x, the limit is 0. Yeah? As I go to infinity, the value of the function will get closer and closer to 0. So the asymptote is this line, y equals 0. If I raise the whole function by 1, then even the asymptote moves up by 1. Yeah? Now the numbers are going to get closer and closer to, they're not going to get closer and closer to 0. They're going to get closer and closer to 1. Does that make more sense?
Yeah.
At least to one person? What are we doing on time? Huh?
1 over x plus 1 is 1.
1 over x plus 1 is
1.
the limit as x goes to infinity of 1 over x plus 1 is 1. If I don't put this, 1 over x plus 1 will never equal 1. This is impossible. Because for this to be true, you would need this to be 0. Correct? That's obvious. What is a number that you divide 1 by a number and it's equal to 0? It doesn't exist. Yeah? You cannot divide 1 by a number and get 0. It's impossible. Right? Therefore, this is not possible. This cannot be true. This is bigger than 1. But now what we're asking is not, what is this equal to? Right? When I ask, what is this equal, I'm saying, what is the point on the function? What does the function give me? And the function, we said, will never reach 1. But if I ask, what is the limit of the function? What is it getting closer to? Not becoming equal to, but getting closer to. The limit of this is 1. So this piece here is very important. You can't forget it. This and this are two different things. One is the function itself, and the other is the limit of the function. Those are two different things. And maybe this will help. We'll do a simpler example, actually. I hope you had read the section in the textbook, because it would help. If you have not read, then all of this is new, and it's a lot maybe to process. But if you've read in advance, then it didn't all make sense, maybe, but you have some idea what we're doing. So we'll do a simpler example, right? If I have, we'll use the same graph, 1 over x. Why not? 1 over x. Now, if I ask you, if I'm here, I changed my mind. We're not going to do 1 over x. We could, but I'm going to just use a line, 2x. Just because the numbers will be easier. Okay, let's take a number here, or a point here. We'll call it the point 3. 3 what? Loveness? If you're going to be on your phone, guys, you might as well leave the class. You don't have to sit here and listen to me if you want to be on your phones. 6. Now, if I start at the point, let's say 2, let's say this is 2, and then I move closer and closer, let me make a table. Yeah? So if I'm at the point 2, this is my x, and then there's f of x. So what is f of x when x is 2? 2. No. What is f of x when x is 2? Love. Our function is 2x. F of x is 2x. That's our line. So when x is 2, what is f of x? 4. When x is 2.9, what is f of x? 5.8. The 9 becomes 18 like this. 1.8 plus 4 is 5.8. Right? And then what is, if it's 2 point, and so 2.9 is here. That's 2.9 and 5.8. Good. What is 2.99? What is the f of x? So let's do some algebra. I'm gonna I hope you're also taking notes, yeah? Some of you discovered this week the value of notes and the problems you have if you don't take notes. Okay. So 2.99 times 2 is 2 times 9 is 18, 2 times 9 is 18, 2 times 2 is 4. I have 1, so 8, 9, the 1 and the 4 actually go together. That's 5, and the dot goes there. So 5.98. Okay, let's go one further, 2.999. So I want to get closer and closer to 3, but I don't want to reach 3. I just want to get closer and closer to x equals 3. Yeah? And I want to find out, is f of x getting closer to something? So we add another 9. And what is that? Okay, that's, put the 2 there. That's still 18, 18, 18, and 4. That's 8, 9, 9, 5, and the dot goes there. So 5.998. And maybe you see a pattern. If I keep going, 9.9999. I'm going to get 5.9998. And I can keep going, right? These numbers are clearly getting closer and closer to 3. Are these numbers getting closer and closer to something? 6. Which is obvious. If I get closer to this point, well, I'm getting closer to the values of the point. This is a simple example. So now we could say the limit of 2x as x approaches 3, yeah, we're getting closer to the point 3. The limit of this function as x approaches 3 is it's getting closer and closer to 6. Yeah? So in your mind, you're thinking, if I'm moving closer and closer to this point, so the x, this is the x here, take these guys out there. This is the x-axis. So x is 2, x is 3. I'm getting closer and closer to 3. I don't want to reach 3, but I want to get as close as I can get. Then the numbers on the range are getting closer and closer to, here I've got 5.8 and 5.98 and 5.998, and I'm getting closer to 6. I'm not going to reach 6 because 6 would mean that I have reached 3. I don't want to reach 3. I want to get closer to 3. In this case, it is, hold on, let me not keep Mr. Benjamin waiting. One, two, three. So you're saying, I mean, yes, the function exists at 3, and it has the value 6. But when we're asking what is the limit, the idea of a limit is, I will demonstrate. When you draw a function and you put a circle and you keep going, do you know what this means? Has anybody seen this before? It means I am puncturing the function, right? This is a function, it's continuous, yeah? All the numbers, all of these inputs are valid. This is the domain, from here to here. Yeah? That's the domain. This point, let's say it's 3.5. This point is not in the domain. I have removed it from the function. That's what the circle means. It means the function exists, right up, 3.49999999999 is part of the function. 3.50000000001 is part of the function, part of the domain. But 3.5 is not in the domain. The function doesn't know what to do with 3.5. 3.5 doesn't, there is no, we don't know. It doesn't, it's not in the domain. We can do this in math. We can draw a function and say the function exists everywhere except here. I take out this point. I decide this point, the function, I don't know. Hindi kudziwa. Yeah? It's gone. I don't know where it went. So I'm going to do the same. So now, my function doesn't have 3, 6. 3, question mark. I don't know. 3 is not in the domain. Yeah? I know it looks like it should be 6. And that's the point. It looks like it should be 6. Shouldn't it? Yeah? Because it's the limit. Your eyes, it's a natural thing. You look at it and you say, but it goes, right? If I get close, it becomes 6. So you know what is a limit. You look at it and you go, but sir, it looks like it should be 6. And you're right, it looks like it should be 6. You already know how to do a limit. You say, but it's getting close, if I keep going, I will reach 6. That's the point of the limit. Even though the function does not exist here. So f of 3 is undefined. Yeah? But the limit of f of x as x approaches 3 equals 6. F of 3 is undefined, but the limit as f of x as x approaches 3, that is 6. So here we're just writing, using math notation, what you know already in your mind. You look at this, you say, well, it looks like it should be 6. Right? When x is close to 3, then the thing becomes almost 6. Okay? That's a limit. That's all it is. As I get close in here, as I get close in the domain, so the limit is asking, I'm moving in the domain. In the domain, I'm getting closer to this. And I'm asking, what am I getting close to in the range? This is the domain part, and this is the range part. As I move in the domain, I'm getting closer to 3. What am I getting closer to in the range? That's the limit. That's all. And the reason the limit is also interesting is when you puncture a function like, I don't know if puncture is the mathematical word, I forget, but we'll call it puncture, poke a hole. When you puncture the function, right, it still passes the vertical line test, right? Here, there's 1 point, 1 point. Here, there are no points. That's okay. It's not in the domain. It doesn't break the, yeah? And here 1 point, 1 point, 1 point. So it's a function. Because there's no point here, what can I do? I can add another point. I can say that here, this is the point of the function. So f of x equals 2x, except if f of 3 will equal 8. We'll call this 3, 8. I can do that. You might ask, why would you want to do that? I don't have a great answer right now, but you can do that. And now we would say it's not that f of 3 is undefined. F of 3 now equals 8. But the limit of f of x as x approaches 3 is still 6. As you get closer and closer, you're getting closer to 6. Even though the function at 3 is not 6, it's 8. So the limit does not care what is the value of the function at the point. Right? You don't care what f of 3 is when you're doing the limit. The limit, f of 3 can be whatever it wants, it can be undefined, I don't care. When I'm asking about the limit, I'm just getting closer to 3 in the domain. I don't care what happens at 3, just what happens when I get closer to 3. That's all. Okay. I think we can stop there. Hopefully, we have made a good advance in the concept of limits. And I hope that you realize that you know how to take a limit, right? When you look at this, you say, well, it looks like it goes through. It looks like it should be this. And you're right. That's what a limit is. Now we're just giving some mathematical precision to that statement, because we are going to use this concept of I'm getting closer to something without ever reaching it, in order to, remember the first thing I said, what is the rate of change of this thing that is not a line? I have a graph, a function that is not a line. How fast is it changing? What we wanted the slope of the secant. We said as the secant gets closer and closer to the point. But if it reaches the point, then I don't have a line anymore. To have a line, I need 2 points, right? I can't take the slope of a point with itself. Right? So I'm going to take these slopes as they get closer and closer, but they will never reach. And so we need this concept of the limit to now go back and calculate what is the slope of a function that is not a line, not a straight line. Chabuino. Zikomo. Thank you for the assignments, and I forgot that I had some assignments to grade this week, so I have not marked them, but I will mark these and the other ones for next week. And I will send you the assignment, the problem set for next week shortly. Have a good rest of the day. Sorry? No, on limits now. The next problem set will be on limits. You had a rest already. You had a rest already. This is good for you. Hey. Oh, sorry. Do I even have the sheets? That's a good question. Okay. Can we turn off the